Like she said, Steve Cyphers. I work for a company, GHD. It used to stand for Guttridge, Haskins, and Davies. We've, rebranded down small, been around for 80 years or so. This is me. That's kind of my office footprint. I've worked in several of those offices. I'll stand here so you can hear me. I also want to say that my Twitter handle over there, if you would like to make this talk interactive, my notifications are on now, so feel free to heckle me from wherever you are for the rest of the day. I will try not to put you to sleep because this is not exciting stuff, I'll be honest, but it was intriguing because I had to build something, thank you, had to build something to go from one Siemens product into another Siemens product, which was quite funny to me because the client that engaged us had an out of support element in their GIS, and they wanted to do some network flow modeling in another package. So I don't want to go on about me too much, but yeah, working for an engineering consulting firm is really fun because we get lots of interesting problems thrown our way, and my go-to hammer in the tool set is always FME. I'm a tragic, if they don't want to hear FME can do that, they shouldn't ask, because that's always my go-to thing. And I can't stop. I've been screwing around with FME for about 10 years. I used to install it off CDs, get really excited when it came in the mail, all that stuff. It was great. But yeah, why we are here specifically is we're doing network load analysis. So we are talking just network topology, building electrical network topology. So not just snapping and connectivity as a GIS sense. We are building it where it did not exist, because the GIS for this client is very representative of like a pole and some wires running through it, whereas to get a wire past a pole, there's actually insulators, terminal, you'll see. It's very exciting. I was going into this. GIS data, poles, wires, and equipment does not necessarily make network topology. So this is, I don't know if you can read that. That's awfully small here. Dale tweeted something about a transformer joke, and I followed that with paint it green, call it custom. And that was thud. No one got it. So anyway. But anyway, that was a while ago now. That was right after they both got electric cars, because I remember that, because I was very, very jealous at the time. And they overloaded the one at the office. Sorry, that's a background story. Okay, typical workflow in FME. You sort of take the problem apart, and you go, oh my gosh, what have we done? You sort of do the whiteboard stuff, and then you break the thing down, you sort of solve it in parts. I should say this was a collaborative effort. I had several team members helping me. Simon Laird in my Melbourne office and Carly Illingworth in my Melbourne office. We worked on this together, which was great. We came up, batted our head against that collaborative workspace stuff a little bit, because what we were doing was a lot of primary and foreign key stuff. So it is just this one horrible poster workspace that just everything gets written out and everything, all the QA drops out the bottom. It's not super great, but we suffered through that, and then we crushed the problem. So one of the things we did have to do, which was, for the client's sake, they were worried about the schema design of the PSS Sincal database. So what we decided to do was use a third-party tool, which gets installed with Sincal, to drive, using DLLs to create the empty schema for us. So we used a third-party, just a syscaller, to drive a little exe, or let's see, actually it was a little bit of VB script, I believe, anyway, and then we were running that through a syscaller. It would actually create a nice empty database schema shell, which we would then recycle data from a standards type library, because there's a lot of, that way we'd only have to maintain data in another database, and then the data would get written out, and we could maintain version continuity with whatever Sincal database version they have. I keep doing that. Sorry, I'm stepping out of the audio shell. I'm pretty noisy though. But what this does is write out a .sin file, which is a header So that's all Sincal needs. And then luckily the back end is just an access database with a horrible schema. But that's why we cheated and used this little DLL, because it would actually just create all the empty, nice, beautiful tables with all the primary foreign key relationships. It was great. So one piece was they provide a name, and then it would actually then just create the empty shell with the given name, and we were just versioning these things up as they were running through their equipment. And I don't know if I actually mentioned, sorry, in my head I've explained everything, but that's not true. Oracle SDE, ArcFM, and then there was a gap to get out of their GIS into this other product, which is just this access database with a header file. We abstracted it up and away because it was a very huge geographic area, so we sharded out their network into subcomponents and voltage. We had a couple areas of their network where we actually had the 11,000 and under, or no, over voltage settings. So we just had like a simple worksheet, because we are dealing with people who, they weren't strong in FME, but we wanted to build a tool that they could just run this sheet, and then as long as they didn't monkey around with the standards type library, which would break things, then this would actually run and create and keep their version control, in order, and actually point to the older database, because we were reusing some of their schematics and rolling them forward. Success. Crush the problem. Because that, you can see 3 transformers, right? Way less than 10. Not really. So, in a high level, create an empty database using their tool, driven with FME, but using their tool, so that's in order. We're actually then reading the geometries from GIS and kind of, reshaping them into the way they write geometries, which is entirely different and quite hilarious, and then had QA traps to cycle back to inform the GIS processes where they were having some snapping issues and things, because we couldn't really trust neighbor snappers and things to do the work, because we are talking substations and bus bars within utility, so you cannot snap in that sort of environment because they're like that far apart physically. So it got really weird. So we had to not trust the geometry, but we could say where it's not maintaining rigorous rules, where we needed it to, we could pass it back and just flag it to them and say, hey guys, something's not quite right, have a look at these. And again, an Excel table. So that was the recycling. Because the first time through the process, if there is no existing schematic, and I stole that out of their PDF, that side, I need to source that so we can put this online. You have a schematic, because we're generating from the GIS data these, which is, that's not what it looks like in the real world, but that's like how the engineers love seeing it. To them, that's like good map, like that. GIS has it actually laid out to where it actually is. The first time through, however, it looks like, do you guys ever remember the auto layout function? FME? It looks like a really over-the-top version of that, because it will just throw nodes in the order it receives them and lays them out across the canvas. And the first time through it is quite painful. The user has to then kind of lay them out. But then once that version is saved, those schematics are rolled forward into each set. So it's a continual improvement on the schematic. But we didn't really want to actually trade map coordinate units for roughly schematic units, because there wasn't really a good correlative. We did sort of that, but that got them a good start, and then they had to lay them out how they wanted to see it. Okay, so all in all, we're running using FME in a startup script to drop in the empty part, reference a standard type library, use also the ArcFM GIS data, which actually all that's really doing is expressing some of the GDB domains and fields and that sort of thing as attributes. That's as far as we were using it. We weren't at an Arc objects level. We were using it on actually machines that may not even had Arc installed, so they were probably using the API level of the reader. And we were dropping out error tables back to inform the GIS process so that the 3 or 4 officers could improve the data and continually move forward. But at the end of the day, I don't have my preview slide, so I don't know if I'm not there yet, sorry. So yeah, to reiterate, the left-hand side are the sort of the features and attribute tables that we're sort of talking at within Sincal. Those are the important ones. There's lots of other secondary tables that we're kind of talking to, but that's sort of the feature classes that I need. There's about 20 or so tables that I can actually get written to describe geometry and attribution within Sincal, so they can do their load flow analysis where they're under and overloaded. The whole point of that was to look at their network and see where they can prescribe rebates or do rollouts for LED lighting or solar panels, so to save them from having to hang more copper, because that was always what they would not like not to do. And the geometry. Okay, I think we're going to get into the geometry part. I alluded to at the beginning, poles and wires in a GIS is very different from like electrical topology, and we'll kind of go into that. And the way Sincal manages that is all those tables on the left using primary and foreign key relationships between all these other tables. Very simple, integers. It can be really anything, but we use counters and integers to keep it relatively simple, because yeah, it was actually an integer key field. Sorry, I'm thinking back. It was a while ago. So here's the, oh, sorry, a little out of order. Here's the nice ugly poster, because everything writes out to the right and all the QA drops out to the bottom. I make jokes that there's more tunnels than Gopher Mountain in this, because there was really no way to really tidy this up. I mean, I think given maybe another 3 months, you probably could without breaking something, but that's kind of what it looks like in the main script. So you have a bunch of readers on the left, which sort of fan out into sort of the networks that trigger. So we saw the Excel table at the beginning, and it was a yes-no sort of run, and those are all readers to pull those pieces of network out against like a region polygon. So they could just have to evolve that shape to know where that bit of network started and stopped as like a catchment basis of their network. And then it was passing out to the 22-ish tables in the access table, and then about 20 QA tables, which directly related to the ones that if you're having a problem, we had a QA trap to inform backwards. And this is my shout out to Mark. We, as always, I think given more time, we would love to provide a artwork workspace script. That's always the, you want to be tidy, elegant, clean, so it's easy to debug if things go wrong. We did not achieve that here, but it's a work in progress. The client is quite happy and they use it sort of every quarter, but we have to ask them, can we actually give you this one? Because this one looks a lot nicer and it's annotated a bit better, but they are actually using it in anger now, so it's still working for them, but I'm a little unhappy with how it went. It's not very pretty. So yeah, geometry, right. Because we're talking an access database and not like the old Esri personal geodatabase, these are specifically, the geometry is stored in a point, like a table of just like sequential ordered list of points. So every polyline is actually split and using nodes. And let me think, does it start at the end? Endpoints. So every line, it has an endpoint, and then the nodes are calculated towards the middle, and then those lines are actually dropped into a table, and the one that repeats is dropped, because you don't need the middle one twice. And we had to do a little bit of buckle points, it's called, sorry. And then those get rattled through into this other table, and you maintain your primary key of like what line that is. So there was a lot of that sort of thing going on, broadcasting to other little subtables. And endpoints and terminals I described. To actually maintain electrical connectivity where a line stops, you actually have to have a node at each end, but you have to have a connector, a terminal between each line. So that was another trick. And this is props to Takahashi. This is how you actually grab the first and last node out of a polyline. I don't know if you can see I can actually get the mouse to fire up. See the index, the -1 there, and the index of 0. That's a really neat trick. Oops, sorry. neat trick. But yeah, then we're taking the first node, last node, dropping the geometry and creating the points, because I needed the terminal and I needed the endpoint and I needed to drop a terminal at the same location. So into another table, because they were just like all going everywhere. And then a bus bar. Complicated again. You have like an attachment point at a bus bar. So where these in the GIS, it's just a node connecting to another line, and you're going to have many lines connecting to a single node. You actually had to, let's say, fan out and increase the connectivity and the location of like where it's connected, but also a terminal and endpoint terminal, and then the bus bar connection point. So it's all getting a bit silly to force electrical topology into GIS data which doesn't have it. But this is our leap to throwing the data over the wall from ArcFM into this other product. And it goes on. Capacitors, batteries. It's similar to the bus bar. It's like a battery on the network that will hold charge and pass it on, but there's usually a voltage drop on either side of that. So, but the end result, this is where they're headed. Looking at a network, we're then, not we, they, we're looking at their schematics and maps and looking where they're under and overloaded on their network. So the red area, they would be saturating them with coupons and LED lighting and solar panel rebates to try and like lift the overloading state of that area of the network. And then in schematic view, it's the same sort of thing. Like they're looking at like, in the schematic view, it's overloaded here, which means a lot to the electrical engineers, whereas the map is more informative to the stakeholder engagement team. Excuse me. Future directions. Years ago, Mark and Dawn did a good webinar on, actually I don't know what the CIM stands for, but it's an open sort of import-export middleware piece that they could actually export out of the GIS and then import to the other side. And because it was XML, that was Don's, he was all over that. And I was really hoping to leverage that and tried to get the client to head in that direction. So then we were leveraging, Sincal's tool to make the database, which can read the CIM data. And all we had to do was create really well-formed XML data. But I think they just wanted us to not do that. We couldn't get some of the features working because the CIM library was a bit limited because that was 5 years ago, I think, when that was done. And the standard types library has grown quite a bit. So there was a lot of ground to cover, and they said, no, let's just stick towards the access avenue, which allowed them to have a bit more of a QA/QC channel back to their GIS team. But we did a lot of SQL queries for QA internally while the thing was running, so we lifted those schematics to pass them through using a lot of executors and things to lift the old schematic and pass that directly through and compare it against the table. And then as new elements dropped in, those wound up on the QA table as well. So we had to go, these need to be drawn to the schematic and then run it again, and then they land. So that's kind of how that was always working. Continual improvement, but it is very much a roundabout to get the data in and out. So thank you. That was very interactive of you. I appreciate it. I invited my friends to heckle me via there. But if you have any questions, I know it's not terribly exciting, but I'd love to hear from you.
Thank you, Steve. I have a mic. I'm willing to walk. Personal questions are also allowed about his Twitter.
Yeah, I'll read those.
So making sure that I understand correctly here, were you dealing largely with the geometry issues that tend to be part of, you were building a new network schema partially, correct? Or were you dealing mainly with their existing infrastructure not being geometrically accurate in the GIS?
A little bit of both.
Bit of both, okay.
Yeah.
Yeah, because with ArcFM utilities, you've kind of abandoned that and did more with FME.
Yeah, because they were sort of, I don't know if it was out of maintenance or no longer supported. I wasn't really privy to that whole part. We were tasked with, this is what we have and this is what we need, and we were going to puzzle our way through that and solve it for them. But it just turned out that the path of least resistance was just creating the empty shell schema and populating it using all the primary key structures to just enforce the data. But it was essentially just exploding GIS data how we know it and throwing it into a different way of thinking about it, because it was thrown across, like we're talking three or four feature classes, and it's now talking into 23 tables to do the same thing as a couple of feature classes over here. So really puzzling to us. We got really well and very familiar with their documentation on what Siemens Sincal needs, and we'll see. I would love to actually make this as a service, but I think it would be too weird to handle every scenario, because we actually tuned it specifically and bespoke, unfortunately, to their data. But we were not bringing through GIS attributes per se, voltage, some of those things, yes, but we were introducing topology rules that other product needed, was kind of what we were doing. We had to jump through all those hoops to make the software work. Sorry, I'm out of the mic. Too much dancing.
So in transitioning to the schematic view then, was it just the line geometries that were changing? Were the actual points, meaning the poles or whatever, were those static?
Yeah. Given, is GIS data not perfect, and we're talking remote environment, single wire earth return, sort of remote sort of places. The wire may not be snapped to the pole. We really, we were kind of showing the network at this scale, so we weren't really concerned about that. Where it got weird was in the substation levels, where if things were closing on us, it could be that bad, where your 66 kV is like a little too close to the 22s, and we had to make sure that those problems were caught and sent back to GIS and going, hey, this isn't even allowed. This can't happen. Those kind of things got passed back to GIS, and they put a bit of airspace or made sure things were doing what they needed to do, because enforcing some of that weird electrical topology was our end game, and that was the QA loop. We were just going to tune up the GIS data well enough so it still represented the features to their location accuracy, and attribution was sort of another, well, it did improve that as well, I'll be honest. They actually started seeing like, wow, that capacitor isn't even on the network. Oh, okay, now it is. Hey, that works now. So it did improve their GIS data, but it was more around getting these out, because the network modeling group needed this. They need this seasonally, twice a year. They really have to know what they're up against, because they get their seasons of storm and all that stuff, but they're also against development, which they really have no control over, but they're responsible for servicing those areas. So they need to know, as things develop and become overloaded, how can they change their network at a least cost sort of way, via, like the rebates I was talking about. That's often the way they approach, but also if push comes to shove, some of the developers can go in and, they might bring in another line off of a lower, underloaded part of the network to service that area, if they can, to bridge in from another side. So, sorry, did that answer?
Yeah.
Yeah.
Maybe just a quick question. You mentioned a script you're using to create the output schema.
Yes.
Which was MDB, anyway. Did you consider, or did you try using a template on the writer, on an MDB writer before?
Yes, but we're not provided a template with the installation materials, and it was that wasn't least resistance path, I'll be honest, but that was mostly to retain continuity, because as the firm would get say their Sincal was upgraded, and because it's a Siemens project or product, it's every 6 months, no joke, like to the day. So there's no delay. It's a German product. You get your update every 6 months. We wanted to maintain version, parity. So a template may not have worked because that I didn't trust. So this was good because we were relying just a bit of C script and off it goes, and it actually hits the DLL and just drops out the empty shell. And then from that point, we take the name that we were provided as a parameter, and then we go and fire hose it and blast all the tables. So it was workable. But that because we're also providing this completely over to them to run. So we have the Excel table and go, I want that, yes, no, no, yes, or yes, all of them, and then they run out the batch and do that on their areas.
Okay, thank you, Steve.